If you subscribe to the channel, you'll get lots of interesting videos like this one. And if you like the video, it'll really help us out. Please comment down below for any other interesting things. That also really helps us out as well. Hi, welcome to another edition of Easy Theory. So let's name some problems that would be interesting here. So we just did the Fibonacci numbers and introduced this idea of smart recursion, otherwise known as dynamic programming. And so what are some problems that I would like you to work on? So the first one is, what are the runtimes for the two algorithms that we just did? So the one about the naive Fibonacci number calculation versus the smart one where we store the previous calculations in the table. And it turns out to be really interesting because you have to really think, what are the sizes of the numbers that we're dealing with here? Because if you think of the number n, how big is the Fibonacci number for n compared to in terms of its size relative to the starting number n? So that might be something to see. And then the second one is there a faster way? And I'd like you to always think about this, because once you get, let's just say one of them is a linear time algorithm, big O of n, then if you find a big O of n algorithm, you may think, okay, yeah, that's the end of the line. But it turns out that you can actually go a lot faster sometimes. So if you think of, say, I want to calculate y to the n, where n is a integer, y is an integer, let's say. So y and n both are integers. What the naive thing to do is just to say y times y times y times y times y, and do that n times. And assuming, although this is a bad assumption, that each multiplication can take constant time, this is a big O of n time algorithm, obviously, because each one takes constant time. Again, that's a bad assumption. But it turns out that we can do significantly better, because what we can do is note that if we're doing the same operation over and over and over, so we can actually do some kind of splitting type idea that we did with the two sorting algorithms. Namely, if I try to figure out y to the n over 2, and therefore what I can do is I can square this number. So if I can figure out this number, then I can just square it, because all I have to do there, because in order to get y to the n is just multiplying this exponent by 2. So what we can do is something called repeated squaring. So repeated squaring is a really nice technique to build up a power of an integer power of an integer, or really any number, but an integer power. And what you can get out of this is a big O of log n time algorithm, which is obviously better than big O of n because log n is exponentially smaller than n. So this is actually much, much, much better. So what I want you to actually think about is there a faster way than the smart recursive algorithm that we did when we stored the previous calculations? So hopefully those are interesting. Put those into your answers into the comments, or your ideas, or any other interesting questions you have. And as always, I'll see you next time.